Hello everyone, in this video we shall understand aromaticity. First we shall understand the word meaning of aromaticity. Aroma means fragrance. So earlier the compounds which having the pleasant fragrance, those are called as aromatic compounds. So then the later the definition of aromaticity or the aromatic compound has been changed and evolved. And now the definition of aromaticity is it is a character of an unsaturated cyclic molecule that possesses additional stability as a result of the arrangement of pi electrons associated with the unsaturation of the ring system. Means when you have the cyclic unsaturated system and due to the same electron density above and below this molecule, due to this character this molecule gets the higher stability or the additional stability. This property is called as aromaticity. These type of compounds are called as aromatic compounds. And this is a benzene. Here you can see that this is the electron density above and below. Due to this benzene is higher stability, gets the higher stability. Because of that it called as aromatic compound. The resonance energy of this benzene is 36 kilocalorie per mole and it is stable compound. It is stable aromatic compound. Okay, then which all compounds are to be called as aromatic compounds and what are the rules for the aromaticity? As we are discussed in the definition of the aromaticity, the rules of aromaticity are: it must have uninterrupted cyclic cloud of pi electrons. Means the molecule should be cyclic. The molecule must be cyclic so that there will be uninterrupted pi electron cloud will be there, so that the molecule must be cyclic. And the next one, hence because of that each atom in the ring should have p orbital. Each atom in the molecule should have p orbital. And the next one is the p orbital must be able to overlap with the p orbital of the next atom. This p orbital must be overlap with the p orbital of the next atom, so that then only the electron cloud will be there, uninterrupted electron cloud. Hence the molecule should be planar. When the molecule is planar, then only the p orbital of one atom overlap with the p orbital of the next atom. Hence the molecule must be planar. These are the three main, that is cyclic. It should be cyclic. Every atom or of the ring should have p orbital and molecule must be planar. The next one is the pi cloud must contain an odd number of pairs of pi electrons. Means this aromatic compound must contain odd number of pairs. This is one pair of pi electron, this is another pair, this is another pair. So that here you can see that this is 3 pair of electrons. Not the pi electrons, it is a pi electron pair. Here you have this pi bond having one electron pair, means there are 2 pi electrons. Here also 2 electrons, here also 2 electrons. Odd number of pairs of electrons. Here we have 3 pairs of electrons in the benzene. Like this, the pi cloud must contain an odd number of pairs of pi electrons. For this rule, there is a mathematical way to express this rule. That rule is called as Huckel rule. This rule is called as Huckel's rule, or it is also called as 4n plus 2 pi rule. Means the molecule must contain an 4n plus 2 pi electron system. Then when the molecule is containing 4n plus 2 pi electron system, it is called as, it obeys the Huckel's rule. Then that the meaning of that is that system is containing odd number of pairs of pi electrons. Okay, then we shall understand what is Huckel rule. Huckel rule means it is 4n plus 2 pi electron rule. Here the n is equal to 0, 1, 2, 3, 4 and so on. When you add the 0 in the place of n, in the first, when you add 0, you are going to get 2 pi. When you add 1 here, you are going to get 6 pi. And when you add 2, you are going to get 10 pi. then 14 pi, so on. So when your molecule is having 2 pi system or 6 pi system, 10 pi, 14 pi and so on, then this is called, it obeys, that molecule obeys Huckel rule, then the molecule is aromatic. Okay, we'll take one example for this Huckel rule to understand what is Huckel rule. Here you can see that the molecule, and let's take the another molecule. Here you can see that this is having 2 pi bonds. This is having 4 pi electrons. This system is 4 pi electron system. This system is 6 pi electron system. But according to Huckel rule, only 2 pi system, 6 pi system, 10 pi system, 14 pi system and so on are obeys this Huckel rule. Hence this doesn't follow the Huckel rule, so that it is not aromatic. This is not aromatic. This system obeys Huckel's rule. Okay, here you can see that this is even number of pi electron system, it is odd number of pi electron system. This is the rule number 4. This is also called as Huckel rule. Huckel rule is 4 n plus 2 pi electron system, pi electron rule. Here n equal to 0, 1, 2, 3, 4, and the system should have 2 pi system, either or 6 pi or 10 pi or 14 pi and so on. Let's discuss the benzenoid and non-benzenoid aromatic compounds. Benzenoid aromatic compounds means the compounds containing benzenoids. Okay, let's check whether these compounds obey the rules for aromaticity or not. Here this is benzene. Each carbon atom in the ring, this is cyclic compound, cyclic, and it is planar, and each carbon atom in the ring is sp2 hybridized. And check the Huckel rule, means the rule is it should contain the odd number of pairs of pi electrons. Here this is 1 pair, say 2 and 3 pair of pi electrons, hence it is 3 pair of pi electrons, hence it obeys the rule, that the Huckel rule is having 6 pi electrons. And this is 1, 2, this is also cyclic, uninterrupted p orbitals, and planar 1, 2, 3, 4, 5. It is also obeys, and this is 10 pi electron system, and this is phenanthrene 1, 2, 3, 4, 5, 6, 7. 7 means 14 pi electron system, and this is also 14 pi electron system. So that these are benzenoid aromatic compounds, and these all obeys the rules for aromaticity, hence these are benzenoid aromatic compounds. And let's see the non-benzenoid aromatic compounds. Non-benzenoid means these compounds which don't have benzene ring, those are called as non-benzenoids. This is pyridine. Here the pyridine, the nitrogen of pyridine having pair of electrons on the nitrogen. The pair of electrons on the nitrogen, these are in the sp2 orbital, these are not in the p orbital, and the p orbital is used for the formation of pi bond. Hence this is nitrogen also sp2. This is planar, cyclic, and uninterrupted p orbitals. And just check the pi electron system, apply the Huckel rule. 1, 2, 3. It should not contain the pair of electrons in the nitrogen, only this 1, 2, 3 pi electrons, hence it is also 6 pi electron system. Okay, because the pair of electrons on the nitrogen are not in the p orbital, they are in the sp2 orbital. Okay, but in the case of pyrrole, here the pair of electrons on the nitrogen, the pi electrons are in the p orbital. Here you should consider these 2 electrons, and these 2 are involved in the unsaturation. Here you have to consider these 3, 1, 2, 3 pair of pi electrons. This is also 6 pi electron system. This is also obeys the rules for aromaticity. This is also aromatic. Oxygen again same, here also 3 pairs of pi electrons. This is also 6 pi electron system. Sulfur also same, 6 pi. Thiophene also same, 6 pi electron system. Here again imidazole, the nitrogen, this is same as the pyrrole. The electrons on the nitrogen of this nitrogen are not involved in the unsaturation. That means they are in the sp2 orbital. Here these two electrons are in the p orbital, but these are involved in the unsaturation. So that you have to consider this electron, not this electron. This is in the, these are in the sp2 orbital, but these are in the p orbital. So that these are involved in the bond formation. Pi, these are called as pi electrons. 1 2 3 pair of pi electrons, and this is also 6 pi electron system. This is also, here also these electrons on the nitrogen as well as this, the electrons on nitrogen are both are in the sp2. sp2 of this, sp2 of this, the electrons are in the sp2, hence these are not involved in the unsaturation. Only 1 2 3 pair of pi electrons, and this is also 6 pi electron system. And these are called non-benzenoid system. And also there are fused benzenoid system. It means benzene is fused with this pyridine, and these are called fused or condensed aromatic compound. These are also aromatic. Here again the same, this is just like pyridine, the electrons are in the sp2, are not in the p orbitals, hence 1 2 3 4 5. 5 means 10 electron system, 10 pi electron system. And this is, but this is pyrrole system, just like pyrrole system. These two electrons are involved in the conjugation. 1 2 3 4 5. Again indole is 10 pi electron system. These are also aromatic compounds. Let's understand some more about the aromaticity by taking some examples. This is cyclopropene. This is, see, this is also having p orbital, this is also having p orbital, but this carbon is sp3 hybridized. This carbon is sp3 hybridized. As per the rule, each carbon atom should have the free p orbital, but it does not have free p orbital, hence it is not aromatic, and this is not aromatic because one carbon is sp3 and there is no free p orbital, hence there is no uninterrupted, hence there is interrupted p unsaturation. Okay, hence this is not aromatic. As well as this this is cyclopropenyl anion. Here you can see that the one pair, here another pair of electrons, hence it is 4 pi electron system. As per the Huckel rule, it should have 2 pi electrons, it should be 2 pi electron system, 6 pi electron system, or the 10 pi electron system. But 4 pi electron system does not obey the Huckel rule, hence it is also not aromatic. This is also not aromatic because it does not obey Huckel rule. Huckel rule. Okay, then this is cyclopropenyl cation. Here you can see that this is also, this carbon is, now this carbon is having p orbital. Now this carbon is having p orbital. Count the number of pi electrons, only 2 pi. This is 2 pi electron system. As per the Huckel rule, 2 pi system is obeys the Huckel rule, and 2 pi system is aromatic compound. It's aromatic compound. Uninterrupted p orbital is there. When you write the resonance structure of this, resonance structures will be like this. So that this is aromatic compound. Only the cyclopropenyl cation is aromatic, but the cyclopropenyl anion and cyclopropene are not aromatic because here it is there is an interrupted p orbital. This is having sp3, and it does not obey the Huckel rule because of it is 4 pi electron system. Hence cyclopropenyl cation is aromatic because it is having 2 pi electron system and it obeys the Huckel rule. Next example is cyclopentadiene system. This is also not aromatic as in the earlier example cyclopropene. This is also having sp3 carbon, hence it is also not aromatic, but its pKa value is 15. So that this is highly acidic. Why this is highly acidic means when it loses one proton from this, and it loses one proton from here, it will be like this. Now apply the rules. It is planar, cyclic, and there is an uninterrupted p orbital, and count the number of electrons in the unsaturation. 1 2 3 3 pairs of pi electrons, hence it is an odd number of pairs of pi electrons. Apply the Huckel rule. 2 4 6, it is a 6 pi electron system. This cyclopentadienyl anion, this is aromatic, hence this cyclopentadiene is highly acidic. When it lost proton, it will become the stable aromatic compound. To get the stability, stable aromatic compound. This is not aromatic, but when it lost proton, it will become aromatic, because that this compound is highly acidic, having pKa 15. Next example is cycloheptatrienol bromide. This is cycloheptatrienol bromide. This is also not aromatic because this carbon is sp3. This is also not aromatic. This is in the covalent form. When you get the in the ionic form, okay, this is called a trophylium cation. Check the aromaticity of this one. It is having, this is same as a cyclopropenyl cation. 1 2 3 pairs of pi electrons, hence it is 6 pi electron system, planar, having uninterrupted p orbital, hence this is stable aromatic compound. This is stable aromatic compound, hence this tropylium cation is aromatic. But this cycloheptatrienol bromide is not aromatic because it is in the covalent form. It is the ionic form of this is tropylium cation. This is stable aromatic compound.